Welcome back, students. Today we will start the second video of combinational circuits, and the topic of today is design procedure for combinational circuits. And this topic is the most important topic in order to gain the concepts regarding how do we design the things in combinational circuits. Let us suppose we are being given a problem that we need to convert a BCD code into a XS3 code, and we are being told that you need to design one IC for it, or they will be asking us, tell us what will be the logic diagram for converting a BCD code into an XS3 code. Now we have to think in terms of designing the things. Now, and in order to think in that way, these 4 steps which have been mentioned in the slide will be very helpful for us, and this is the approach we have to actually follow while we'll be solving any question based on combinational logic circuits given. The very first point is, from the specifications of the circuit, determine the required number of inputs and outputs and assign a symbol to each. It means that whatever is the question given to us, according to that question, we have to decide first of all as a designer how many required number of inputs and outputs shall we assign. Let us suppose we take this example that we have given here, example 1. So we know that BCD code is like an 8421 code. So it means it will be having how many bits? 4 bits. And XS3 code will be again having how many bits? 4 bits. So it means that if suppose we take this example, I need to have 4 inputs and I need to have 4 outputs, right? So this will be my 4 input bits, these will be my 4 output bits. Now the next thing that is being told is that you have to assign a symbol to each. It means, how do you name it? Let us suppose if you are naming this these 4 bits as A, B, C, D, so you may name the outputs of the XS3 code as WXYZ, or it can be anything as per your choice. So this is the very first step, that we need to determine how many inputs, how many outputs, and give some names. Second thing is that we have to derive the truth table that defines the relationship between inputs and outputs. Now how will we define the relationship? That will depend on the problem given. Let us suppose in this example, if we take this example further, let us have some codes here. These are suppose BCD codes, right? What will be their XS3 codes? Now this being a truth table, we know that XS3 code is obtained by simply adding 3 to the BCD code. So this will become 8 and 8 will become 11. Now how did we write all this? It is as per the behavior that exists between BCD and XS3. So this table that we are completing here, this is called as the truth table. We will see this again in the upcoming classes. Truth table is nothing but a table where we'll be having all the maximum input combinations on one side and the corresponding outputs on the other side. And there's a relationship also. If suppose you are having n number of inputs, then we can have 2 to the power n number of input combinations in a truth table. So it means if we are having suppose 3 inputs, so normally we will be having around 8 you can say rows in the truth table. So this is the second step that is being told. Now we come to step number 3. Obtain the simplified Boolean function for each output as a function of the input variables. Now once our truth table is complete for all the combinations, after that what we have to do, we have to simplify the Boolean functions. Now for simplification, we can use K-maps as the best method. Otherwise, if the table is sometimes very simple, you can simply use Boolean algebra, and the aim is that we will solve it and we will get a simplified equation. The last thing is, once we will be getting the simplified equations, the last thing is that we will create a logic diagram. Let us take one example to understand step number 3. If we talk about the full adder, we say that after solving equations and all, the equation of sum is going to be A XOR B XOR C, right? Now if we get this equation is our Boolean function. Now the last step would be then draw the logic diagram. Now how will we make a logic diagram of this sum? It would be simply, we will be having gates, and because XOR gate is being mentioned, so we can take two input XOR gate with A and B inputs, and this will be given to the C, and this is the final output, so we can name it as sum. So this is the fourth step of the design procedure, right? So just to summarize before we wind up, what are the four important steps to design any kind of a combinational circuit, any kind of problem that is being assigned? Your first step should be, you should determine how many number of inputs and outputs are required, then assign names to it. Second one, depending upon what relationship exists between the input and the output, you should make a truth table. And in step number 3, once you will get a complete truth table, you should try to solve it using K-map or Boolean algebra, and you should get a very simplified equation. And once you will get a simplified equation, after that, depending upon what logic is being used, like here XOR gate is being used, we will create a logic diagram. So these are the 4 steps to design any kind of a combinational circuit. So that's it for today. I will see you in the next class. Take care and have a nice day.